Hi guys, welcome to another episode of the Common Lisp Study Group. I'm your host, Ron Batum from Atlanta Functional Programming. I have my usual suspects for discussion here, Judd online, as well as Michael Fiano and Michael Gargano. Hopefully a few others will continue joining us as we continue our discussion on the object-oriented features of Common Lisp, which is spilled over from Chapter 16, which is what we discussed last week, into Chapter 17. Last week we touched a lot of base on generic functions and generic function machinery, which is often used for doing multi-dispatch. And it's also often used for implementing, say, instance methods. And it is the basis for implementing instance methods inside Common Lisp. This week, what we'll be discussing really is, class definition. How are classes defined in Common Lisp? What sorts of things can you do with the built-in classes that are available, and so forth. To start things out, Common Lisp is a single class hierarchy, much like Smalltalk. There is a top-level object. It's called T, capital T. And it splits into really two different types of families. You have your built-in classes, which is integer, string, list, vector, a lot of stuff that were basically primitive Common Lisp data types. And then you have user-defined classes. Now, the reason that this distinction is there is that with the built-in classes, you can't actually subclass them. So you can't make a more specialized subclass integer of integer or string and so forth. But what you can do with the built-in classes is you can extend them. Now, modern languages have adopted this kind of thing, at least if you use languages like, say, C#, where you can actually take a built-in type and specify methods on top of that built-in type has extensions to it, so that people of users of your extension library will be able to use those methods, but they're actually not part of the standard library. So it will give you some more consistency across your application architecture, especially when you are writing methods that are actually acting on those objects, but without having to resort to defining your own user-defined wrapper class along it, just so that you can specify some additional behaviors for it. For the built-ins, at least with respect to the built-in classes. With respect to user-defined classes, though, user-defined classes, almost all of them are actually subclasses of the class standard object. Standard object is really the glue that takes the user-defined classes and sticks them into the overall class hierarchy that's part of the Common Lisp system. This will take a little bit getting used to, but I think if you just keep that in mind in the fact that T is the top level classes, built-in classes you can't really subclass them, but you can extend them, and user-defined classes are, if you don't specify a direct superclass. So if we look at this, this is how you would define a class. You would have def class name. You would have a list of one or more direct superclass names, and I'm being very specific about this, and the book was very specific about this, because there are implications about superclasses when you start getting into notions of multiple inheritance, which we will discuss later. If you don't specify any in this list, which I will just highlight, in this list of direct superclasses, then by default that name is a user-defined class that's a subclass of standard object. So that's how it actually gets hooked up into the rest of the machinery for Common Lisp. A couple of notes that I thought would be good reminders for folks is class names are in a separate namespace from functions and variables, which means just like functions and variables, you can have a function and a variable with the same name. You can have also a class with the same name. So that sort of also complicates kind of the entire, symbol resolution. So when you're looking at, a piece of code, you have to look at the entire context to really understand whether or not.
Yeah. Those that are familiar with Scheme or other Lisp ones, A lot of people refer to Common Lisp as a Lisp 2 because it has 2 namespaces, but actually it has 7. Peter Norvig talks about that in his paper book. But yeah, there's 7 different namespaces in Common Lisp, so it gets confusing. You got to really read the code.
Yeah, that's a very interesting thing. Like I keep hearing more and more dimensions that are in Common Lisp. I was like, this is yet another namespace that I have to remember. Oh man, this is going to get a little ugly. But did you say that it's in PAIP? It's in Paradigms of Artificial Intelligence Programming.
I believe so. I know it was Norvig that said it. I'm not
Okay.
sure if that was the book he said it in.
Okay, so I will find out for you folks where it was said and what those other namespaces are other than these 3 that we've just mentioned here, so that we can actually have a complete picture of the namespaces that are actually available inside Common Lisp. Again, like I mentioned, class names themselves are they're just argument that when you want to create an instance of a class, you just pass it as an argument to make instance. And that has a symbol, which I'll show you later. And the make instance function is what is used to actually go and create instances of user-defined classes. As I mentioned before, all classes do directly subclass standard object, and if you want to subclass something else, you have to specify in that list of direct superclass names that I showed itself. So a couple of other notes on before we get started on looking at some code, and that is the notion of slot specifiers. Slot specifiers in Common Lisp is, I think, the almost exact equivalent to instance variables in modern object-oriented languages. There are different ways of accessing slots. One way is through accessor methods. This is your normal getter and setters, and you can either define them yourselves using def generics, or there are actual macros that are available that you can hook into each slot, which I'll show later, that will give you that generated function already. Or you can use the low-level slot value function itself to access the instance variables. And there are certain cases where that becomes useful, and there are actual convenience macros that will make it safer for you to actually leverage the slot value functionality. And I will go ahead and show you that. To start off, though, when you're defining a class, last time we went through a more complicated example, but I would start with this, which actually shows off some of the basic features. All you need to do is define your class if it's a top-level class, say that you won't have any subclasses, and then specify your list of instance variables or your slots, and you're done. This is the most basic class that you could define. There are even more basic ones that you can define, especially when you start leveraging, say, mix-in functionality. But this is how you would actually define a top-level class if you're not, doing much. And of course, when you're wanting to subclass, you could go ahead and do this. This is an example of an object that has a single direct superclass. So is savings account. So when we run this inside the REPL, and we wanted to define, say, a bank account, you will see that to access some of these, oops, hold on, I don't like this. This earmuffs has to be there correctly, otherwise I'm going to kick myself. When you're accessing now slots, you can do this in a very low-level case. Like in this example, we have, say, we created a bank account that has 2 properties, customer name and balance, and if we wanted to set them, we could just go ahead and do set f on the slot value, and slot value is a 2-parameter, actually I think it's it's a 2-parameter function that takes in the object as the first argument, and the slot name has a quoted symbol as a second argument, and you can then access that particular slot inside the object itself. And it is packed. It is actually next to each other in the object representation. So although you wouldn't have to know about that unless you're doing something really interesting. Obviously, just like we did sets, we can also get using the same mechanism here. So if we wanted to access what we just setted, you can see that we'll access the appropriate property to the appropriate property inside the object and get its exact value that we initialized it to. Now, this, creating blank objects like this, when we're just using, if you notice here, there are very rare cases where you would create an object using this kind of notation, using specifically, actually, make instance with no keyword arguments passed on it. I don't know of any realistic situation where this is really done. Often there are other ways of actually constructing objects. I will show the 3 ways that the book mentions, and I don't believe there are other ones unless we start getting into like the mop. But these are the standard ways of going through it. One is you need to tell make instance at least that there is a name for this property when you're initializing it, and that is through what's called init arg. Init arg allows you to specify a name to an instance variable that is a keyword argument into make instance. And it could be the same or it could be different names from the property name that's actually specified in your slot. I'm not sure if there's an exact best practice. Michael, you could probably correct me if I'm wrong, if there's a best practice on specifying keyword arguments for objects, but as far as I know, there isn't, and it's really up to the designer to design their object hierarchy any way they want to define it as. Init form is another property that can be specified on each slot.
What was your question about keywords?
So for init arg, is it good practice to name your slot specifiers the same name as the slot itself? That's in. So if I do in this example, just to show you, I named my slot customer name, right, and my init arg is still customer name. And if I made an accessor, it'd probably be also a customer name. Should it be consistent, across the entire definition of the slot, or would you want to make this M customer name and then?
No, it doesn't have to, and I'll explain why. But well, when we get to reader methods and accessors, I'll comment on that.
All right, excellent. All right. So init form is another way of controlling object construction. It allows you to specify a Lisp expression, and that is, again, be used to compute a specific value for a slot if no argument is passed in to make instance. And then finally, for full control, we have this, I would say, is the closest thing to an actual normal object constructor with full control to all access to all the instance variables, and that is initialize instance. It's the most generic method that's available for controlling object construction. Now, I'm going to be honest, 95% of the time, the init arg and init form combination with make instance will handle the majority of your object construction needs.
There's actually a 4th case too.
There is a 4th case. Okay, so we'll
and it's actually used a little bit more than, well, it should be used more than init form.
Than init form. Okay, so what is the 4th case?
Default init args.
Default init args. All right. Oh, right. So you can actually copy another object construction and then
it's useful if you were to subclass a class, instead of specifying init args for every single one, you just specify default init args, and that's better for multiple reasons. I'm not going to go into them because there's 20 reasons why that's better, but if you just Google default init args versus init form, there's like a couple links. Zach Bean from Quick Lisp commented on it. They come up first in Google. Just look that up.
For more information on this, this is probably a very good thing that I'm going to go ahead and tell our viewers here. Look up init form common Lisp on Google.
I don't remember the exact specifics, but there's quite a few good points that he brought up regarding that.
Advantages using default init args. Now, I will say though that that it's realistically, in realistic cases, even if we have default init args, 99 to 95% of your object construction needs will be handled by in order of usefulness. I would say default init args, then the init arg init form combo with each of your slots, and then finally, if you need really full control, and there are some cases, especially if you're like computing like types of accounts, and if you have computed properties in your object instance that need information on the values that are being passed in to other member variables to compute their actual initial state, that's when you would want to actually use initialize instance. So an example of all three is, let's say that you have, going to our continuing example of bank accounts here. Let's say that you're creating a bank account and you want to compute, you want internally the account number to be automatically be assigned to the account when it gets assigned, but you want them to specify at the very least the name of the customer that is associated with the account. And if they want, they could specify even a balance. Although if you're making a zero balance account, it could also be, just zero. So in this example, we have 4 slots. One of which I'll explain later is being computed based on the value of the balance that's being passed in. So in this case, you notice that if you don't specify a value, our init form in customer name will kick in, and it will actually go in and do something like the following. It'll say that customer name should be passed with some sort of initial value, and it means that you haven't constructed the object correctly. And if you do specify it internally, it will go ahead and default balance, if you don't specify a balance, to 0, as you can see here. So what's so great about this, right? What does it matter, right? In this case, well, if you want to compute account type, you need to at least, and you need the account type based on, how much money they're putting in their account. You need to actually define a method specialized on the bank account. So this is what this method is. Now, the most common way to actually define initialize instance, because the way initialize instance works is make instance actually calls initialize instance, but it calls it after it leverages the primary options of the init arg init form combo that I mentioned earlier. So what you'd want to do is define to prevent initialize instance from actually interfering with that combo of initializing other members that are independent of what you're actually going to use initialize instance for. You'd want to create an auxiliary method, specifically an after method that defines, what you want to do to the object once it gets constructed. So in this example here, what we did is our initialize instance method actually goes in, grabs the balance, and then sets the account type based on whether or not the balance is over $100,000 or over $50,000, which default would be a bronze account, which is 0 or more. Now, you may have noticed here specifically the key argument that's at the end of the definition. The reason this is here is because make instance leverages it. It actually has it in there, has an argument. It needs to be consistent. Otherwise, it complains that your initialized instance has not been defined. And I can actually show an example of this. So if I do this, it complains that you're attempting to add an after method on a generic instance, and it doesn't match the function signature.
Yeah, if you remember last week, every def method has an associating def generic for a generic function, and that def generic's function signature never changes. So all the methods have to reflect that.
Right, and one of the best things, one side effect of this, actually, because of this generic method implementation, is that you can go ahead and specify additional.
You can add additional keyword or optional arguments, sure, but the primary arguments have to be consistent.
Right.
And the ampersand key has to be there if there's keyword arguments.
So at the very least, you have to write your methods this way, which is arguments, and then the key has to be at the end. But you can almost certainly add additional key arguments, and what this does is it allows you to then expose those arguments when you create when you actually create an instance, because now the Common Lisp system will be aware of what you're attempting to add. So if you notice in the function signature, and I don't believe I can actually make the mini buffer any larger than it is here, you will see that after init args, the first option, the first option is opening bonus percentage, which is exactly what we specified here in our initialized instance definition. So it's really cool. I mean, it gives you some abilities to customize how object construction can be created. Of course, you have to be careful in maintaining a certain level of just put 5,000 here. So you need to. It gives you some flexibility, but you have to maintain, at the very least, a base signature of the generic function that you are overriding in order to really leverage the full power of this. Otherwise, you may as well just stick with init arg and init form. And honestly, my personal recommendation is unless you're doing computed properties, and that is again properties that are instance variables whose initial values are dependent on other values being passed into the object constructor, there should be no reason why you couldn't just leverage either default init args, as Michael mentioned earlier, or the init arg init form combo that I just showed some examples of. So let's move on to some of the limitations of using slot value directly, which is the basis of, honestly, the accessor functions. And there are a couple of them. One is, honestly, not coding to the interface or coding to the implementation. Like, it leads to a very tight coupling between the code uses and the implementation. If you suddenly decide to change the structure, the data structure to how a property is being represented in your object, well, guess what? You broke a lot of code that directly accessed the slot value. Also, slot value is set effable, which means that there are cases where you want more control, access control as to who can modify it, that slot value will not be able to give you. So what you can do is you can define in the basic situation a function that does this for you. Of course, you can also define, you don't want to do that if you're creating like class hierarchy. It's better to just create a def generic and an implementation on top of the class itself. And the same thing goes with setF methods. Now, those of you who are coming from other languages, this probably might look foreign to you. I can attest to that. It was very foreign to me when I first learned it. A setF method is basically allowing a user of your library to leverage the same variable assignment methods that are available in the common Lisp system to assign to properties of your object. And the way you define a setF method is you create a 2-argument list. The first argument of this list for the function signature would be setF, and then a symbol to represent what the name of the function will be, and then you could go ahead and specify your arguments this way. And then what it does is internally, when the common Lisp system sees somebody using setF and sees customer name, it automatically knows that it should actually generate setF slot value and the object and slot specifier for that particular piece of code. This generates it automatically. It's a hint for the compiler once you've actually defined the setF method. Now, of course, just like before with reader methods that we just I showed you earlier, you would want to probably leverage the generic function machinery too, as well here in this case, and specify a setF method on customer name. Now, instead of doing all this, because this obviously looks like some best practices that you'd probably want to keep in mind of, what you can also do is in your object, you could specify what's called a reader property, and you can say, okay, the name of my reader property is this guy, and if it's a reader, what happens is the object-oriented machinery will make a flag. So if someone tries to actually modify a property that only has a reader on it, it will go ahead and complain, saying that there's no generic function that exists of this name. And what a reader property, all it does is internally, it just doesn't define a setF method. It doesn't define what we just talked about earlier. Of course, you could also have a writer property too, as well, where you define a setF method like so, and that actually generates an additional method that will hook into the common Lisp machinery for people to actually look up properties. This happens so often that what common Lisp also provides is a third option if you want both, and that is the accessor method. Now, Michael, you were mentioning that that you wanted to mention something about names here at this point.
Have we talked at all about packages, exporting symbols, and whatnot?
No, packages is a couple of chapters later.
Okay, I don't want to jump the gun or anything then, because that's kind of a more advanced topic.
Okay, gotcha. All right, let me then move on. Accessor methods.
It's not important.
Okay. It's not. The point earlier is not as important. Okay. Okay. I'll just keep going here. So, for those of you who probably are looking at this accessor method and say, well, why can't everything be an accessor method? Well, obviously, good old design dictates, like, you'd want, certain things to be accessible, certain things not to be accessible, but readable so that people can have access to the information, and so on. So I would generally not recommend you using accessor unless you are defining a reader and writer. If you end up seeing yourselves doing a reader and a writer like so, then you should change yourself and say, okay, I'm going to create an accessor instead inside your objects. But that being said, don't just make everything into an accessor, because that could be grounds for trouble later on.
Right, especially if you're, well, we haven't talked about it yet, but if you're exporting symbols for your users, by exporting an accessor, you're noting to them that they're able to setF it, when that could break your whole program.
And that is going to be very, very bad. That is nuts.
If there's no protection there, and they think it's supposed to work, but it just brings the whole world down with it, you got problems when you could have just made a reader. And by the way, you are not limited to just one reader or one accept. You can actually make multiple and name them different.
Right. So you can also do something like this, you mean, right? I've seen this, but I don't know in one case it's like customer name and then reader the customer or something like that. Or
an example would be like a reader method called customer name like that, but then an accessor method prefixed with a %sign that's not exported, just to signify that the owner of the library yourself can write, but users cannot.
Right, and that actually brings up another discussion that we're just going to go to shortly.
And that's kind of like the gist of what I was going to talk about earlier, but I didn't want to get too complicated because we didn't talk about packages yet.
So one thing that was kind of interesting is and you just alluded to this is slot value versus accessor methods, and this was actually, you know what? Before we get to that, I'm jumping the gun a bit. There's one more thing that I want to mention before we start talking about slot values and accessor methods, which is inside. Hold on 1 second. Pulling up separate notes here. All right. Inside your slots.
I would actually. Okay, go ahead.
Oh, what?
I was just going to say that usually it's almost always a bad idea to use slot value because you're directly manipulating slots and you're not going through that reader protection.
Right, and I was just going to start introducing what width slots and width accessors are, and I think I was going to recommend that if you see yourself going into that low level situation and you need to use something like that, width slots and width accessors are available that would handle some of that for you. So you almost always would want to just end up using defining accessor methods and then using width slots or with accessors for your other needs. That way it will clean up your code rather than constantly calling slots all over the place and having something like this, which is in our original implementation. It'll access a balance, and you'll start seeing this all the time. Oh, I'm doing account dot balance this, account dot balance this. Look at this compared to using something like, say, width slots, and you'll see the difference. Here, you're just treating it as a balance. This is just telling you internally, well, it's telling Common Lisp that this is a member variable of this object, or it's an instance variable of this object that I'm trying to access, and I'm just accessing it through its accessor machinery, and it will account for that for almost all cases. Now, to be honest, and this is something that I wanted to bring up for discussion, which is the differences of when to use width slots versus width accessors in general. Width accessors seems to be like it's already been handled with slots, so why would you use with accessors anyway? Because with slots already will give you that functionality for you. So when would you use one versus the other? Would it make the code cleaner in the long run?
Well, with accessors actually works on any method. Like, it doesn't have to be in the class specification.
Okay.
Okay. And also, both forms, with slots and with accessors, allow you to alias them, like your line that you're on right now.
Right. But this is already available, is what I'm saying. Like with slots, if you look at this,
right.
like you see this.
But again, if you're using with slots, which internally uses slot value, you're bypassing all that protection, and it just bad code smell to me.
Okay, so you're saying that, okay, gotcha.
Accessors work on methods. Like, you could define your own method that's not even in the def class form, and that would work with accessors.
So
it wouldn't work with slots, because slots are slots.
Would this, because the book seemed to point out, and I think this might be my misunderstanding of what the book said, but of course, it could be something else.
Yes, accessors are not limited to accessors.
Okay. Okay, because he said, oh, the only time you'd want to use this is if you're going to do accessors. And then I was like, okay, so you're saying that when I have a reader only, I shouldn't use with accessors, I should use with slots. But what you're telling me is that's not the case. I can almost always leverage with accessors, and it doesn't matter. It'll just look it up and call the appropriate thing.
Right.
Okay.
Right.
All right. So folks, there you have it. With accessors is probably is a safer bet than with slots, because with slots has some you're losing a lot of protections that with accessors would give you, but with slots and with accessors does the same thing, which is fundamentally it allows you to assign a list of variables to the appropriate accessor for an object. So in this case, let me just change this so that you guys can actually see what this is. Yeah, I'm going to go ahead and do this. Hold on. Shoot. Problem with... So this is the same example as the with slot example, as you can see here. And the difference is you can also specify other things. Obviously, I won't, use them all. This is like one or more, objects that could be specified inside this list. It's not a single, it's like a let form, essentially, where you have variable name is the first argument of the 2-item list, and the property name in this case and that is the slot specifier that's inside the object that you're trying to access. This is a list of these variable property name pairs that are being passed into with the accessor, and then once they're bound, you could just use those variable names as is, and the code will generate accordingly in terms of accessing the appropriate object instance method and go on. So that's a bit of a complicated explanation overview, but it is definitely the kind of flexibility.
Okay, I got some clarification on that actually. An accessor, according to the hyperspec, is not it's anything that accesses, anything that performs an access, and then it says C, reader, and writer.
Okay.
So reader, writers, and accessors are accessors. As odd as that sounds.
Well, they're different types of accessors, which is what I thought. But fundamentally, unless they explicitly say in the hyperspec or somewhere that it says this is what they are, you can never be too sure. So I just wouldn't want to actually mention.
I knew it worked with readers. I just had to find in the hyperspec to make sure. If that was allowed or if that was some SBCL specific thing.
So the final thing that I wanted to mention regarding slots that before we start talking about inheritance really a little bit more in discussion is this option called allocation. Now I'm going to read directly from Practical Common Lisp for the sake of us discussing this, but this option basically allows you to specify whether a slot is an instance level access or a class level access. And when a slot has a class allocation, according to the book, and I have to go and look this up in the hyperspec, the slot has only a single value, and that value is actually stored in the class and shared by all instances. But it goes on to say, and this is where it confused me, like basically, folks, if you see in this example here, we have two classes, a base class, foo, and a subclass bar, okay? Now in bar, notice that bar has another member variable called B that shadows the superclasses B. And the way it works is it will recognize this being more specific than the one that's foo's been defined, and it will use whatever properties that are associated with this guy as being the default for any instance of bar in any of its subclasses that doesn't redefine it. Now, one particular note that you might see is this allocation class guy. And what this does is according to the book at least, is it is a global, well, it is a family shared variable, but it goes on to say that because you cannot actually access a class allocated slot without an instance of that class, it is not actually the exact same thing as class methods or class fields that are in other OO languages. So I'm not entirely sure where this is particularly useful. One thing that he suggested is if you're creating like a resource pool, all right, like let's say that you're creating instances of class and all of these instances have access to, let's say, like a database connection pool, right? At that point, you would probably want to save the database pool itself as a class allocated slot, and then have each of your instances access it internally. And it's primarily, and the only reason you do that is to save space. Instead of having a separate object to deal with it, you now have one object that, when constructed, will internally initialize the entire pool for all future instances of that class. Does that make sense?
Yeah, that's I've never even heard of that before, but I'm reading the hyperspec about it now, and it says that yeah, they're all shared slots for all classes, but if a subclass of a class defining that shared slot specifies a slot of the same name, then it's no longer shared.
Interesting. So
that's pretty much all it says about that. I've never seen it in code that I've read. I've never used it myself. It must be one of those rarely used features of clause because clause is so huge.
It probably is, but this sounds like a pretty useful feature if you think about it, fundamentally at least, right? I mean, it might be a nuanced feature that is only in very particular cases, but I could totally see this being useful in the situation of, say, resource management, because that's a lot of times you have to put a lot of, infrastructure in to properly handle shared resources amongst, classes, right? And especially if you're trying to create a singleton of a particular object, you have to also pay particular attention to making sure that it's only one instance of that resource and so forth.
Yeah, I can see it being useful, like if you were creating, hundreds or thousands of instances, instead of being evaluated every instance that you create, it's already pre-allocated in the class.
So it was one of those features that I forgot that was there, but it's come to think of it, it's actually something I would probably end up implement, if not inventing, myself, just because I need something like that for resource management. But it's already there in Common Lisp. So I'm going to end this discussion on inheritance, really, and there's two types of inheritance, but I wanted to specifically deal with direct inheritance first before we start talking about multiple. As you may know, direct inheritance in classes, by now, I think I've mentioned this multiple times. Classes behavior inheritance is primarily due to the generic function machinery that's available. That is, you are dealing with, if you defined a method specialization on a class A, it is applicable not only to direct instances of that class A, but also to all of A subclasses. Now, one weird thing that I saw when I forgot about this is how Common Lisp resolves situations where there are common names. Now, Common Lisp has this ability where each given object can have only one slot with a particular name. Pretty basic, straightforward, right? But what happens is subclasses could also have slots of the same name as its superclass. All right. In this situation, Common Lisp tries to resolve it by merging all those specifiers with the same name and create a new single specifier with a unique slot name. Now, this is particularly interesting, primarily because of, and I think it goes back to Common Lisp's lack of types when you're defining, a class. But it does seem to me to have grounds for a lot of undefined behavior when you look right down to it. Now, if you're careful and you know how to define your object hierarchy, this could be a boon because it does allow for ultimate code reuse, and you know that Common Lisp will try to merge everything together. However, I would be a bit careful about that when you're doing that. So I thought I'd at least mention it here, and at least give you an example. And again, this example was the example that I was showing you earlier. Let's say you have, foo and bar. Here, B, behind the scenes, will technically try to merge itself up with the B of the superclass. But then, when it's talking about allocation, the allocation properties of the slot is determined by the most specific class. So that means it's determined by bar rather than foo. And that's mainly for instances of bar, not instances of foo, because once when you're instantiating a subclass, all these merging conflicts and merging rules apply. Not when you deal with top level classes. It's not bidirectional.
Yeah, that's kind of weird. I'm kind of confused about that because if bar is a subclass of foo and bar's B has a class allocation, then what happens to foo's B?
Foo's B is pretty much gone, from my understanding.
That's just mind-boggling.
It's pretty much, it basically says to people of instances of bar, you have access to foo's accessor method because you are a subclass of foo, but in terms of its semantics, it's wiped out. It doesn't exist. It's not. It's almost unique. You may as well name it something else. This is something that.
Yeah, I wouldn't rely on that because it would screw me more. It would screw me up completely.
Yeah, it will totally screw me up too as well, which is why I was when I looked at that and I saw that, I was like, huh. In what situation would that ever be useful? So, the last topic in OO, and we're done with our tour of OO in this class, in CL, and I haven't touched, and I'm giving you our OO introduction. We haven't even begun to talk about things like the meta object protocol and how stream hierarchies are available, and we will touch base about this later, but conditions has its own object hierarchy too as well that needs to be at least mentioned. It is a separate Common Lisp's exception handling. This is just a very simple statement to entice you to read ahead. It has a condition system, and standard condition is a separate object from standard object. They're siblings. They're not actually inherited from one another. And this is, for those of you who are coming from, say, systems languages like C++, this is very much like C++. C++, as most people know, the object-oriented system there. Standard exception is not a subclass of some base object. It's rather a separate class itself and has a separate hierarchy altogether that you need to handle. But one thing that confuses a lot of folks when it comes to at least inheritance is multiple inheritance and how Common Lisp handles multiple inheritance. So first I want to define what multiple inheritance means in Common Lisp. All right. When we started this discussion on classes, we talked about the fact that a class can have one or more direct superclasses. All right. Now, this enables you to essentially define a class to have direct top-level classes, each of which that would specify some very unique behavior to this subclass, right? But a couple of things to note about this is class specificity in terms of method invocation. So, for the sake of our example, I decided this is at the suggestion of the book to go through what this money market account class would do in the case of methods that are defined on the money market account object, like any instances of this. So you see in this example here, we have this class that's a subclass of checking account and savings account. All right, nothing pretty major here, but what is important is this guy, which is the order of how invocation will actually work. In traditional things, it's a left to right order of the superclasses. So we start with the most specific class, obviously, which is money market. But then we go down and look up everything that's in checking account first. Then we will look up what's in savings account. Finally, we'll go and look up in the generic bank account, and then we go finally to the top level, standard object and then true. What that means is if you're trying to leverage call next method, what we talked about in the generic function machinery discussion last week, to which new viewers, I do request you look at last week's discussion on it, because we did a pretty detailed discussion on how it works. While there is a way to call up the chain that is from most specific to generic, there isn't actually a way to invoke a very particular specific, less specific method in this chain. So that means if you're in money market account and you want to skip using some functionality that's in checking account, but instead leverage something in savings account, outside of defining a function, a separate function that's called in both places, there's no way in the common Lisp machinery that allows you to skip a particular method in the call chain using call next method, and there isn't a specific call next method for with an argument. And that actually is a very important thing, primarily because it forces you to actually think about how do you want to decorate your methods and how you actually leverage them. What was suggested in the book is to make heavy use of auxiliary methods, and auxiliary methods are what we were talking about last time, and these are the before, after, and around methods. In particular, it suggested that if you wanted to leverage this so that there's a generic method template and then specific method additions, you could certainly write your code, which is a coding convention, that will say, okay, we could call next method, and then underneath have after methods for each of these generic functions that are being called for each of the specific classes that will add the additional information for that particular object after it's been called. Now, I will say that it could complicate some things, but it gives you more control. It certainly does give you more control than trying to do what I was suggesting, which is, and what was suggested earlier, which is defining a function and calling it in multiple places. And it gives you more control specifically in the call chain. How do you want this particular function to be called? But that's actually it regarding the intro to object orientation in Common Lisp. Are there any questions or thoughts, really? Because I know we went through a lot of information here. Folks? Discussion? Michael Gargano, you have been very silent throughout this entire thing. I hope I did not confuse you.
No, the book did a good job of that.
The book did a good job of that. Excellent. I'm glad the book confused you rather than clarify particular concepts.
But if you ever get serious with Common Lisp and you actually start using the object system, you will never want to use any other object system. It is very flexible. It's so easy to mold the language into what you want it to do.
Yeah, I mean, it's obviously pretty different, but like what going into like all the details of the merging with the multiple inheritance and stuff. It's not something I'm definitely going to retain for very long unless
it's very flexible. I mean, you don't have to use all these features. A lot of these languages don't even have these features.
So I guess the question is the point is not to really be overwhelmed saying, oh man, I have to use all these features when I'm designing a Common Lisp application. But really,
no, absolutely not.
You want to really be aware of them so that, in your particular case, you'll be like, okay, how do I mold the object system to fit the paradigm that I'm trying to really write for my application? It make it the basis of your object or of your architecture. It goes back to, I think, something that I'm forgetting the exact quote, but Alan Kay once said, about internalization and pointers, and not knowing about how messages are actually being passed. I don't remember the exact quote, but it reminds me a lot about the fact that you want the flexibility of as much flexibility on object system as you can, because it allows you to mold it to a particular problem space, much like how you would leverage macros when you want syntactic extension to actually describe how that problem should be computed. What are you trying to do rather than how do you want to actually explicitly do it. And like I said, we've only scratched the surface. There's things about CL, and in particular about its mop and how it's connected to class, that if you knew how it sort of was designed, it would give you ultimate flexibility in terms of how and gives you the best ability of creating a very high performant application with garbage collection, which I think today, compared to languages that are being touted as being garbage collected, simple, very focused languages, it's still leagues ahead, which surprises me a little bit, that rather than helping the programmer.
One of the big features of class, if you don't remember anything but this one thing, is that methods are completely separated from classes. That is, for example, users of your library can define a new method that operates on instances of your own class. Can even define the same method via one of the around, before, or after qualifiers that goes before your own method to hook into your own functionality and add their own functionality. That's very powerful. Very powerful. Methods on classes are not part of the class. They are just like regular old functions.
So, coming from other languages, I think there's one more, because of recent development in these programming languages, that could probably bring home, this kind of flexibility and why it's important. One is actually related to C++. I can only talk about C++ having this feature, and a related language called D is called uniform function calling syntax. So what classes did is it basically is a form of uniform function calling syntax, where regardless of whether you're dealing with a function or a normal object, internally the machine really will know what to do in terms of how you would actually go and what that invocation actually means. So as far as you're concerned, you're just, you're looking at it and you'll know whether or not it's a method, function, or whatever based on its declaration. But you don't actually have to explicitly hint to the compiler that this is what it is. It will know based on the context in which it was written in as to whether or not it's a method call or a function call. And I think that's really, really useful, primarily because it maintains consistency. You don't have to remember certain rules about how to call a method, and call an object, and so forth. And in terms of actual design, it makes multi-method dispatch a breeze. Like the lookup table becomes very easy versus in other languages, where honestly, I think multi-method dispatch almost ends up being boiled down to double dispatch. It's never really true multi-method dispatch, and that is one feature that is still specifically unique to CLOS itself. The underlying machinery of the compiler and the runtime may handle it, but as far as the application programmer is concerned, they don't have the ability to deal with that kind of flexibility at all, which is kind of sad. But it's what can you do? But I'm starting next week. We'll be discussing some more formatting issues related to we'll be talking about text formatting and the format function inside Common Lisp, because that is kind of a beast in and of itself. That's something that honestly I could. We'll have an entire hour discussion on it, because honestly there's a lot of features in there that some of which I always end up forgetting are available, and I end up writing it by hand myself, only to realize that, wait a second, I could have done this in format itself instead. But before I go, I thought I would at least do one more kind of shameless plug for our good friend Michael here, and the Lisp Game Jam, which is coming up on April 20th. The sweetness, it's going to be a great. I'm hoping it's going to be a really, really cool thing. It'll be really nice for folks to join us. Oops, to window. Sorry. Oops.
Got just over 3 weeks left, and there's about 40 people registered.
Oops. Oops.
Should be pretty fun.
So I think it'll be great fun. I was hoping to get the game jam window up here, but for some reason my streaming software is giving me some trouble. But I apologize for that. For folks who want to go look for more information, please look at Lisp Game Jam, itch.io/jam/Lisp Game Jam 2018. And if you guys are looking for, if you guys are on IRC, it's if I remember correctly, it is #Lisp Game Jam on Freenode.
Nope, Lisp Games.
Lisp Games? Oh, I apologize. Lisp Games on Freenode.
Nope, no dash.
No dash. All right. Jeez. All right. Lisp Games on Freenode, and if you're of course on the Discord server, it's the Game Dev channel on Discord. But until next time, we'll be reviewing again Chapter 18, which is the chapter on format itself, and giving you some recipes. And just looking ahead for those of you who are online, we'll be talking about conditions and restarts and the special operators in the next couple of weeks. And we'll finally get to packages soon. So until next week, this is Ron Batum signing off. See ya.